Okay, and we are live. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, my dear students, to another academic year. And this year we are starting off by talking about units and conversions. Right, so just before we start, I want to make it clear that physics is obviously one of my favorite subjects, as you know, being a physics teacher. But like everything else, if you want to learn physics, you have to jump in and do the work yourself. So if you want to learn to swim, you have to jump into the pool. You have to jump in the water. If you want to learn how to drive, you have to hold the steering wheel. And you would have heard me say this in class. If you want to be a good physicist, you have to practice physics. So this is the only way you can get good at physics. So what I want you to do is I want you to get your journal or your book or whatever you have, and I want you to do the work, and I want you to do the questions and the exercises. This is absolutely crucial and essential. It is not going to be enough to watch me do the work without you putting in the work yourself. And a lot of the times in these videos, what I want you to do is I want you to pause the video, do the work, do the question, answer the question, and then play the video and check your answer against my answer. Okay, very good. Let's go. I would like to keep these videos nice and short, so let's just get it move on. What we're learning about, first of all, is applying the SI units and performing conversions. And let's go. Okay, so we're talking about metric units of measurement. We don't deal with imperial units in this course, thank God. So the SI unit for mass, for example, is kilograms. The SI unit for length is meters. The SI unit for time is seconds. And those three are primarily what we're going to be dealing with. There are 7 base units in physics. We won't be concerned with all 7. Not for physics 1 anyway. If you're going into physics 2, you learn about the amperes, candela, Kelvin. But for now, we're not worried about that. We're going to be using, primarily speaking, we're going to be using meters, kilograms, and seconds. Okay? Which makes our job easier. Alhamdulillah. Right, so let's have a look. We also have centimeters, which is 1/100. We have kilometers. The word kilo, as I have mentioned in class, just means 1,000. If you see kilo, it means 1,000. So kilobytes means 1,000 bytes. Kilometers means 1,000 meters. Kilograms means 1,000 grams, and so on and so forth. So kilo just means 1,000. Right, what about centi? Centi means 1/100. Centiliter means 10 milliliters. Centimeter means 1 centimeter because it's 1/100. Okay, and so on and so forth. So let's go and have a bit of practice. Now, to begin with, what we're being asked to do is we're being asked to approximate or guess, take an intelligent guess, and try and see what would be the right unit, what would be a good unit to use to measure the following. So we have, to begin with, write down which metric unit of length you would use to measure each of the following items. The height of a person. So for a person, what do you think would be a good measure of a person's height? Would we use millimeters? Do we even need to be that precise? Do I need to say my height is 1,172 centimeters, or can I say 1.72 meters, or do I need to say 1,720 millimeters? Obviously, for a person's height, meters are usually very sufficient. Or if you want to, you can go with centimeters, but meters is quite sufficient. What about the length of a river? Now, rivers are quite long. If we consider the Amazon River or the Nile River, we're talking about kilometers, aren't we? Once again, I would just like to remind you that if you're doing this with me, pause the video, do these, do all of them, and then play the video and check your answers. Length of a needle, we're usually talking about centimeters or millimeters here. So millimeters or centimeters. Width of a pin nib, so that's just the top part of the pen, we're talking about millimeters or even micrometers in this case. Height of a mountain, once again, we measure the height of a mountain in meters or kilometers. Meters or kilometers. And distance from Salwa to Jahra. So this is a city in Kuwait, and that's another city. We're talking about kilometers, aren't we? And of course, if we are considering imperial units, we'll be considering miles, but we're not. We're only talking metric units here. So that's why we're doing kilometers. Which metric unit would you use to weigh each item below? A man, kilograms, which is the SI unit as well. In case you didn't know, SI means standard. Oh, this is a bit hard to write on. Standard international unit, standard international unit. Okay, so that's what we're talking about here. Okay, in physics we have standard international units just like in every other science, right? So why do we have standard units? The standard units makes it easier for scientists to communicate with each other. If I say, for example, my height is 4 chairs, that makes no sense. Which chairs are you talking about? If I say, for example, my height is 17 shoes, again, it doesn't make sense. But if I say my height is 1.72 meters, everybody knows what I'm talking about. Okay? If I say my mass is 80 kilograms, everybody knows what I'm talking about. So that's why we need standardized units. We need standardized units, standard international units that we can understand amongst ourselves. Engineers need to know these units. Scientists need to know these units as well. And quite frankly, just everyday people need to know the units as well. Right, let's keep going. A letter. What would you use to measure the mass, to weigh a letter? Now, letters are very, very light, so I would not go past milligrams or grams. Milligrams or grams is very sufficient. Delivery van. So these are quite big, obviously. Tons. Tin of tuna, we're talking grams, aren't we? Usually they're about 200 grams. Okay, which metric unit would you use to measure the time for each scenario below? Time it takes to eat a sandwich. I know some of you probably take seconds, but normally speaking, we're talking minutes, aren't we? And if you're really slow, you might take an hour, but most of the time, you can probably eat a sandwich in anywhere between 5 and 15 minutes. Time it takes to travel to Riyadh. Let's say, for example, you're in Kuwait and you want to travel all the way to Riyadh in Saudi Arabia. So that usually takes hours. But once again, it depends on your mode of transport. So if you're going to walk there, it's going to take you days, if not weeks. If you're going to take the car, it's going to take you hours. So anywhere between 10 and 12 hours. If you're going to take a plane, it might take you a couple of hours. So if we're assuming traveling via car or plane, then we're talking hours. Okay, time it takes to complete your homework. It depends on the homework, doesn't it? Once again, so it could be minutes, could be hours. Hopefully not seconds. Time it takes to complete one squat. So one squat that's when you go down on the ground, bend your knees, and then come back up. Seconds. Okay. Let's move on. Difference between metric and imperial. So this is for those students that are really curious about it. So the metric units is what we use. That's the base 10 units. So millimeter, centimeter, meter, kilometer. Okay. Then we've got mass, which is milligram, gram, and kilogram. And then we've got capacity, which is liters, milliliters, centiliters. We won't be dealing with this so much here. It's something that we deal with quite a lot in chemistry. With physics, we don't really deal with it that much. In imperial units, they use those in the UK at times, like they use when they're doing mass, they use stone and pounds. In America, they use miles and yards and feet, and for capacity, they use gallons and pints. Now, we won't be using those. We'll just be using the metric units, which, in my opinion, just make a bit more sense as well. So we use metric units in physics because they are simpler and easier to work with. The metric system is based in tens, making it easy to convert between units like millimeters and meters. It's also used worldwide, so scientists can easily share and compare the results. Okay. So what is this metric conversion factor? Well, turns out if you have a ruler, if you look at your ruler, you'll see that you've got centimeters on top, right? So here we go, centimeters 0 to 1. Now it turns out between the 0 and the 1, there's something called millimeters, okay? And how many millimeters have we got in each centimeter? We've got 10. So each centimeter has 10 millimeters. And once you know that, okay, then you can work out that, let's say for example, I've got 20 millimeters, then immediately you should know 20 millimeters means 2 centimeters. 30 millimeters means 3 centimeters. Okay. Now, what about 100 centimeters? How many meters is that? Well, lucky for us, I have one of these right here. Okay. So this is a ruler, a wooden ruler that I use quite a lot. My students know that because I bring it with me to my classroom. Now, this wooden ruler has 100 centimeters in it. So for every, oops, it's very hard to put back. For every meter on that wooden ruler, I have 100 centimeters. Okay, so 100 centimeters equates to 1 meter. Then we've got 1,000 meters, which equals to 1 kilometer, because remember kilo, oh, it's so hard to write on this. Kilo means what? Kilo means 1,000. Always? Yes, always. Kilo equals 1,000. And I apologize about my handwriting. It's just really hard to write on this. Let me try and see if I can get it better. Kilo equals 1,000. Not bad. Okay. 1,000 kilograms equal to 1 ton. 1,000 mil is equal to 1 liter. And 100 centiliters is equal to 10 liters, because remember 1 centiliter is equal to 10 mils. But you don't need to know that. You don't need to know that. So don't worry about it too much. Good. Let's move on. Converting between units. Again, this is crucial. You're going to need to know that. Let's say we're doing a problem on speeds and the speeds are different, then you need to convert between the units. This is why we're learning about this, because you're going to absolutely need this. If you're going to be an engineer in the future, you're going to need this. How many liters should we put in this plane? How many gallons should we put in this plane? Well, we need to do the conversion. Or let's say, for example, if you're going from one place to another, or let's say, for example, you're a doctor and you want to know how many cc's a certain patient needs. How many milliliters do they need per kilogram of, how many milliliters of medication they need per kilogram, or how many milliliters of anesthetic they need per kilogram of body weight. These are real life problems that you will absolutely deal with once you're a little bit older and you're working, or when you're at university. So therefore, this unit is very, very important. Let's move on. This is one way you can convert from, like, you can use those if you want to. I would definitely recommend to my students, to my dear students, that you learn these. Okay, you have to, right? Because it's just something that you use so often that you have to know it. In 1 hour, there are 60 minutes. In 1 minute, there are 60 seconds. Hopefully, most of us know that. In 1 day, there are 24 hours. But then how many grams are in a kilogram? Hopefully, everybody should know, since it says kilogram, that just means 1,000 grams. A meter has 100 centimeters, a centimeter has 10 millimeters, and a kilometer has kilometer has 1,000 meters. Okay, let's go. Converting metric units. So let's have a look. We've got 20 millimeters now, and we want to convert it to centimeters. Now remember, 1 centimeter, one centimeter equals 10 millimeters. We know that. So since we know that 1 centimeter equals 10 millimeters, we've got 20 millimeters, so that equals 2 centimeters. What about this one here? 450 millimeters is how many meters? Okay. So this time it's different. This time we're not going from millimeters to centimeters, right? We're going from millimeters to meters, right? So the easiest way to do this, now you can do that, you can do this conversion, But the easiest way to do this would be to convert from millimeters to centimeters first, and then from centimeters to meters. So let's have a look. So I would do this. I would change it. I would say step one, 450 millimeters to centimeters. I know that all I need to do is divide by 10, right? Because for every centimeter, there are 10 millimeters. So 450 millimeters equals 45 centimeters. And then for step 2, 45 centimeters is equal to how many meters? Well, I know that in 1 meter, there are 100. In 1 meter, there are 100. So it's going to be less than a meter because I have less than 100. In fact, I have about half a meter. Not quite half. I have 45 centimeters. So it's going to be divided by 100, which equals 0.45 meters. Okay? So the answer is 0.45. Let's move on. Half a kilometer is how many millimeters? Once again, this is multiple conversions. So what I would start with is this. 0.5 kilometers to meters. And that would give me times 1,000 because kilo equals 1,000. 0.5 kilometers equals 0.5 times 1,000, which equals 500 meters. And then I will go from meters, 500 meters, to centimeters. 500 meters to centimeters, and that will equal times 100, 500 times 100, so that will equal 50,000. Oof, the numbers are getting really big now. Now, I need to go from 50,000 centimeters to millimeters. Sorry, my Russian ghost comes out sometimes. Millimeters, and that will be 500,000 millimeters. Or, if you're into scientific notations, 5 times 10 to the power 5. Now, let's just do a quick lesson on scientific notations. What does this mean? It means 5, and you see this 10 to the power 5? That just means times 10 times 10 times 10 times 10 times 10. 5 times. Or 5 zeros. That's all that means. So scientific notations are quite easy, right? If you see, don't be scared of scientific notations. If you see 17 times 10 to the power 5, that just means 1, 7, and 5 zeros. Okay? Hopefully not so hard. Moving on. 6,000 grams to kilograms. Well, we already know that kilo means 1,000. 6,000 just means 6 kilos. I like that one. Next, 2,500 kilograms to tons. So you should know that 1 ton, let's say for example you have a van. Here's a van. It's really hard to draw on these. Okay, right. So, and it's really important for me to add the details, obviously, as you can see. And there's even a driver in there, and they are a happy driver. Normally, if you are driving, you will see that in the back of the van or in the back of the bus, it will say maximum load of 1 ton or 2 tons or whatever. 1 ton is equal to 1,000 kilograms. So 2.5 kilos, 2.5 kilograms equals 2.5 tons. 4 times 10 to the power 4 centimeters. Well, let's change that from scientific notations to the normal form. So that will be 4. And how many zeros? Remember, it's times 10 to the power of 4. So that means 10 times 10 times 10 times 10, which equals 4 zeros. 40,000 centimeters. We still haven't done the conversion. So let's change it to meters first. And that will equal 400 meters. And 400 meters is how many kilometers? How many kilometers? 400 meters is how many kilometers? Well, we know that 1 kilometer is equal to 1,000. Is this even close to 1,000? It's not. It's less than 1,000. So it's less than a kilometer. So you get to divide by 1,000 and it equals 0.4. If you want to be pedantic, you can go 0.400. Doesn't matter. 0.4. 4,000 meters is how many kilometers? Once again, pause the video, do it, and then check your answer. We are looking at 4 kilometers because kilo means 1,000. 4.5 kilograms is how many grams? 4,500. Let me just check that. Yeah. 6,500 grams is how many kilograms? 6,500 grams. Once again, divided by 1,000. And that will equal 6.5 kilograms. 3 hours is how many seconds? I like this. 3 hours is how many seconds? Well, I know that in 1 hour, that's the first thing, 1 hour equals 60 minutes, right? And 1 minute equals 60 seconds. And so we have 3 hours, so it's going to be 3 hours is equal to how many minutes to begin with, and that equals 180, and then we have 180 mins to how many seconds, and that equals 180 times 60, because each minute has 60, and so 1.8 times 60, can I be bothered doing it? 180 times 60, always better to check, and that equals 10,800. So the answer is 10,800 seconds. Next, classwork. Okay, I'm going to give you 1 minute, no, 5 minutes to do these, and then you can check your answers. Pause the video, and we're back. These are the answers. Okay, hopefully you got all of these right. What would you use to measure the mass of a book? Okay, we're doing some revision here. What would you use to measure the mass of a book? Grams or kilograms? Okay, depending on the book, really. If it's a small, tiny book, like, do we have a small, tiny book here? Sometimes I do. Sometimes I do, sometimes I don't. Okay, here's a small, tiny book, right? This kind of book, I would probably use grams. This kind of book, I would use kilograms. So, depends on the book. The mass of a car, tons. Convert 4 meters to centimeters. Once again, pause, do it yourself, and check your answers with me. 4 meters to how many centimeters? That equals 400. Convert 340 centimeters to meters. 340 centimeters to meters. Oops, what am I doing? Divided by 100. Because for every meter there is 100 centimeters. So it should be 3.4 meters. Convert 450 grams to kilograms. 1 kilogram equals 1,000 grams. So this is going to be 0.45 kilograms. Convert 1,800 seconds to hours. Well, first of all, let's convert 1,800 seconds to minutes, and that will equal 30 minutes. And then from 30 minutes to hours, and that will equal 0.5 hours. Okay, so you can write the H like that, or sometimes you'll see it written like that. Okay, so once again, you can use that to do the conversion, but as I said, please learn how to do it. This is something that you will be using a lot, and it's very important that you know how to do it. Okay, so let's have a look. 50 mil. How much time should you have for this? So in reality, if you were doing this in the quiz, you should probably spend about 30 seconds for each one of these max. So for all of these, you'll be looking at about 5 minutes max. But with practice, you can probably do it in a minute. Let's see if I can do it in a minute. 50 mils is 5 centimeters, 100 mils is 10 centimeters, 100 centimeters is 1 meter, 2 meters is 200 centimeters, 200, that doesn't look like 200. 6,000 meters is 6 kilometers, 1 kilometer is 1,000 meters, 3 kilometers is 3,000 meters, 8 kilometers is 8,000 meters, 6 centimeters is 60 millimeters, 1 centimeter is 10. So they're really quite easy, those ones. Significant figures, right? So I'm not going to spend a lot of time on this besides saying that, hey, you see the way, okay, is there a decimal place here? No, there isn't. So that's one significant figure. If you need to revise significant figures, there are plenty of videos on YouTube for that. So please go and watch one of these. I'm just going to spend a little bit of time here today because I'm not going to go into the details. I'm just going to show you how these are done. So how many significant figures have I got here? 1, 2, 3, 4, 5, 6. Why are the zeros important here? Well, because they came after a decimal place. If I say, for example, I am 82, let's say, for example, I am 172 centimeters, all right? If I say I'm 172 centimeters, that's significant to 3 significant figures. But if I say I'm 172.00, I'm being very precise. I'm being very precise, which means that those 2 zeros are significant, okay? So it will be, in that case, it will be 5 significant figures. Right, anyway, let's have a look here. So that's 6, that's 1, 2, 3, 4, 4 significant figures. That's 4 significant figures as well. And that here is 5 significant figures. When we're adding different values, the answer is ideally going to be equal to the component with the lowest significant figures. Why? Because that's the one that's least accurate. So let's say, for example, here we've got 6.2 and here we've got 4.113. As you can see, that's to 1 decimal place and that's to 3 decimal places. This one has 2 significant figures. This one has 4 significant figures. Once I do the answer, if I go 6.2 plus 4.114, the answer will be 10, okay, 0.314, right? But it's correct, but because of the inaccuracy here, what I will do instead is I will get rid of those 2. Why is that? Why'd you do that? Well, because you can see here it's to 1 decimal place, and so it's not very accurate. So I can't make the answer more accurate than one of the components. So 10.3 is sufficient, okay? And so if I was to do the next one, I'll just do the next one and then I'll stop. 3.4 plus 8.2252, it's going to be 11.6252, but then I know it's 1 decimal place here, so I'm just going to get rid of all of these. 11.6 is sufficient. Okay? And for, let's just jump all the way here, mixed operations. If you're doing mixed operations, we always follow bed mass or bod mass or head mass. So that depends whether you're American or from the UK or whatever, but it's basically all the same. Brackets first, exponents or exponentials, division, multiplication, addition, subtraction. Brackets, exponents, division, multiplication, addition, subtraction. So over here, I always do the brackets first before I do the multiplication, even if the brackets has addition inside it, whatever it is. Let's move on. Okay, here's where we get to the real physics with conversions, that is. So how to convert kilometers per hour to meters per second. We have a real example here. If we are to compare the speed of a bus and a train given as 20 meters per second and 70 kilometers per hour. So hopefully the 20 meters per second refers to the bus, which is here. So 20 meters per second. And the train is 70 kilometers per hour. Then we will have to bring them to a common unit. I don't know which one's faster because they're different units. So how do I do it? Well, there's one easy way of doing it and one right way of doing it, if that makes sense. Let's see. I need to convert 70 kilometers per hour to meters per second. So first of all, I know that 70 kilometers equals 70,000 meters. that's how much the train does in 1 hour. In 1 hour, it goes 70 kilometers. It crosses 70 kilometers every hour. 2 hours, 140 kilometers. 3 hours, 210 kilometers, and so on and so forth. So, 70,000 meters in 1 hour. I don't want to know in 1 hour. I want to know in seconds, because I want to make it the same as this. How many minutes in an hour? I want to know how, well, let's try and find that in 1 minute. 70,000 divided by 60 minutes, that gives me 1,166.6 meters per minute. And then I divide it by 60 again to find out how many per second. If I divide it by 60 one more time, I get 19.4 meters per second. Okay? So now, since they both have the same unit, meters per second, I can compare them and say the bus is faster. Okay? I need the same units. Could I have done the other way? Could I have done it so that instead of changing the train to meters per second, could I change the bus to kilometers per hour? Most certainly. Let's do that. If you think you know how to do it, then please pause the video, do it, and then check your answer with me. Well, we know the bus is faster, so I'm just going to keep it as it is. But let's see if I can convert 20 meters per second to kilometers per hour. What do? I first of all need to go 20 meters per second to minutes to meters per minute, which will be, let me just put a line here, which will be times 60. So 1,200 meters per minute. And then I want to go from 1,200 meters per minute to per hour. So I'll multiply by 60 again. And that gives me 72,000 kilometers per hour. Or 72,000 is 72 kilometers per hour. And as you can see, once again, the bus is faster than the train. Moving on. This is another conversion tool that you can use. From meters to kilometers, you divide by 1,000. From kilometers to meters, you multiply by 1,000. When you go from big to small, you multiply. From small to big, you divide. Okay? Same thing with time. So we've got hours to seconds. If you're going from big to small, you multiply. 1 hour is equal to 3,600 seconds. 1 second is equal to 1 over 3,600. Right, now comes the easy way. Remember how I told you there was an easy way and then there was the right way? Well, I'm going to teach you the easy way anyway, because it's going to be quite useful when it comes to quizzes and exams and assignments. And I'll be honest, sometimes I use it too. So, turns out some clever scientists found out a long time ago that basically if you're converting from 1 kilometer per hour to meters per second, what you're doing is you're multiplying by 1,000, right? You multiply by 1,000 because in 1 kilometer there's 1,000 meters, and you want to change it to meters. And then you're dividing by 60 twice, which is the same as dividing by 60 times 60. If you're dividing by 60 and then dividing by 60 again, it's the same as dividing by 60 multiplied by itself, or 60 squared, or 60 times 60, which is 3,600. And this here can be simplified. So it can be simplified to 10 over 36 if we cancel the two zeros. Which can further be simplified if I divide by 2. It can further be simplified to 5 over 18. So what does that mean? Wait a minute. What does that mean? It means if I have 1 kilometer, I have 1 kilometer is equal to 5 over 18 meters per second. 1 kilometer per hour, sorry. 1 kilometer per hour equals 5 over 18 meters per second. طيب, really? Yes. So what about 10 kilometers per hour? What does that mean? It means 5 over 18 multiplied by 10, which equals 50 over 18, which is approximately 3 point something, 3.3. 50 divided by 18, which is approximately 2.8. And you see how that works? So it's pretty cool. It's a neat trick to know. Let's move on. So here's some examples. I want you to pause the video and do them. 1 kilometer equals 5 over 18. 2 kilometers equals 2 times 5 over 18. 3 kilometers equals 2. Everybody should be able to know this, to do this by now. 3 times 5 over 18. And then you can actually do it, and which will be 15 over 18, which is equal to 5 over 6, or you can even do it as decimal, 0.83. Okay, let's do the next one. And the next one is exactly the same, but I've just revealed the answer. It's 54 kilometers per hour. You just multiply it by 5 over 18, which equals 270 divided by 18. Which, if you just plug it into the calculator, 54 times 5 over 18, and it just gives you 15. And that's the answer. Okay, let's do some examples. My face is in the way, but hopefully it doesn't change the answer. Given the speed of a car is 72 kilometers per hour and the speed of a bus is 16 meters per second, which one is faster? So once again, we have the same example as before. This time, I always like to draw a picture as well. And I always tell my students, if you can, if and when you can, draw a picture. Draw a quick picture. So here's a bus, 16 meters per second. And here is a car. I'm not so bad at drawing normally, but I'm still learning how to use this. And the car is 72 kilometers per hour. So you have a choice. Either you change this to meters per second, or you change that to kilometers per hour. So this time I'm going to change this to kilometers per hour. Okay, so 16 meters per second. What I'm going to do is go 16 meters per second, multiply by 60, which will give me per minute. And that will give me 960 meters per minute. 960 meters per minute, which multiplied by 60 again equals 57.6, 57600 meters per hour, or 57.6 kilometers per hour, which means the car is faster. The car is faster. Okay. Another way I could have done this is I could have gone 16 meters per second divided by 5 over 18, and that equals 57.6 kilometers per hour. So that would have been the shortcut way. Oh, okay. The other way you could have done it was obviously change the car from 72 kilometers per hour to meters per second. If you're interested in doing that, there's the answer. Do it the other way. What will be the value of 2 kilometers per second to meters per second? Now, please read the question carefully. It's not per hour, it's per second. To meters per second. So 2 kilometers per second to meters per second. Well, that's in second, that's in second. Kilometers per sec. It's just 2,000. Easy. Determine the given value of 18,000 meters per hour in meters per second. What do I need to do? First of all, let me change the meters per hour to kilometers per hour. Okay. Or, no, I don't need to do that. Hang on, I just need to change the time. So I have 18,000 meters per hour, and I need it to be meters per second. So what can I do? That's per hour. In 1 hour, it's 18,000. So let me divide it by 60 to get per minute. So that will give me 18,000 divided by 60 equals 300 meters per minute. 300 meters per minute. And then divided by 60 again will give me 5 meters per. Divided by 60 again. Why divided by 60 again? Because first we divided by 60 to find it per minute. Then we divided by 60 again to find it per second. So it will be 5 meters per second. And that's the answer. But I'm going to get rid of all of this so you can see a much neater answer rather than me taking all the screen. So there you go. That's the answer. Moving on. The distance covered by a moving truck in an hour is 108 kilometers. Now that is a tricky way of saying the truck is moving at 108 kilometers per hour. That's the same as saying that. If I say the distance covered by a moving truck in 1 hour is 108 kilometers, that's the same as saying it's 108 kilometers per hour. Determine the speed of the truck in SI units. Well, first of all, the SI units for speed is meters per second. You should know that, okay? If you didn't know that, that's fine. Now you know. The SI unit for speed is meters per second. So what I need to do is convert from this to meters per second. Now we know how to do that. You can simply multiply by 5 over 80. So 108 multiplied by 5 over 18 equals 30 meters per second. Okay, that's how you do that one. Alternatively, you can go, okay, 108,000 meters per hour and then divide by 3,600. So 108,000 divided by 3,600, which equals 30 meters per second. Find the distance of the object in meters. The speed is given to be 5 kilometers per hour and the time is 2 hours. Meters what? Let me just move my face out of the way. Meters if. Oh, if. Oops. Okay. Find out the distance of the object in meters if the speed is given to be 5 kilometers per hour and the time is 2 hours. The distance? Oh, okay. So distance equals speed times time. So if I'm covering 5 kilometers every hour and I travel for 2 hours, then that means I cover 10 kilometers. Simple as that. It's just 2 times 5 kilometers per hour, which will give me 10 kilometers. It's like saying if you're walking 50 meters every minute and you walk for 2 minutes, then how many meters have you moved? How many meters have you crossed? And you can say, well, 2 minutes, every minute is 50, so it's 100 meters, and so on. And there's your answer. Okay, there's no worksheet. All right, well, there you go. That was easy peasy lemon squeezy, complete by Sunday the 4th of August. Well, no, it's not Sunday the 4th of August. It's Sunday. Definitely not the right date here. Okay, by September. Okay, by next week. Let's just say complete it by next week. Okay, that is the wrong date. I apologize. And if you need any help, you can watch the videos on the YouTube channel, which hopefully you're doing now. This is the YouTube channel. Okay, all the best. I'll see you in the next one. The next one we'll be talking about displacement, distance, speed, velocity, vectors, and scalars. All the best for the year. Take care. Bye-bye.